Assalamualaikum warahmatullahi wabarakatuh. And a good day to Mr. Amran and Mr. Airul. So today I will present the final presentation. Finally, we reached the final. It was very challenging for us to take this course for this year. So before we start, let me introduce myself. My name is Muhammad Syamuddin bin Tajuddin, EA17113. So this is my group member Amirul Izwan and Fong Okai, and our supervisor is Madam Nur Hafiza. So for the first, how we generate idea to solve the problem. First of all, we asking the community themselves. We meet with them. We ask them why they are seeing always clock. And we do inspection on nowadays thing and make conclusion on the system. So we see ourselves the system for nowadays and make a conclusion why it always clock. And next we meet with the expert at the Jabatan Pengairan dan Saliran. So at this we ask directly the expert face to face on and do the Q&A with him. So here is the example of the quick question that we ask during the meeting session. Next is specific requirement. So requirement that must be fulfilled. First, must be able to prevent sink from clog. Second, should able to reduce the water and air pollution. Third, can recycle back, use cooking oil. Fourth, can prevent the blocked drainage system. And fifth, must user friendly and environmental friendly. So next is various sketch of product. So this is the sketch for the solution 1, which is by Fong. This is the fishbone diagram for the solution 1, and this is the design for the solution 1. Next is fishbone diagram for the solution 2, which is proposed by me, and this is the design for the solution 2. For the solution 3, also proposed by me. So this is the fishbone diagram for the solution 2, which is very not very good. Then for the solution 4 is proposed by Amirul Izwan. So this is the fishbone diagram for the solution 4, and this is the design for the solution 4. Block diagram. So first we install machine on the drainage, then connect phone application with machine by using Bluetooth. Then we click button Bluetooth to scan Bluetooth. Application show the process in the machine. Application should monitor the height of solid waste, the motor, the heater on or off. If the solid are full, the application will send notification to the user. User need to clean up the solid waste or basket filter. Then the oil filter out when the resistance sensor detect the value. The oil will store in the bottle. The water without waste flow out to the drainage pipe. Disconnect the application and monitor by display panel on the machine. So this is all the process for our product. Next is the decision metric table. So for the decision metric table, for both three of us have do the weightage, which is for the solution 1, the total score is 18. For the solution 2, the total score is 19. For the solution 3, the total score is 22. And for the solution 4, the total score is 33. That's why we choose the solution 4 as our main product, because it has a high weightage among other solution. So this is the solution decision matrix table, as you can see here.
Okay, good morning. We can see from this video, we can see they have you see when the water go to our product, you can see they have a separable between the oil, food and the water. So you can see for this is to spread between the oil to our product, so we need to filter it out to our bottle again to collect the biomass oil. So these are part for our solid part. So we need to throw out the basket to the trash bin. So after that we need to clean up the you already saw the first video, right? So we continue to this part for the dimension of the product. So what we can see from this the upper part is actually for the sink. We design it for the sink. So they have a diameter is 80 centimeter and the height between the sinky and the product is 45 centimeter. So the product actually is this part where you can see the diameter for the height is 45 centimeter only and the length is 100 centimeter and for the weight is 60 centimeter. So this part is for the bottle of the oil. If the oil was to the filter, they come out to this bottle, and so this part is for the display part. So they have we can see from here we have a 3 section. See 1, 2, 3 section, and these are the flow out. So we can see for I will go to the rotation of this product. Here you can see is the product of the filter for our oil. So that's all for the dimension of this product. So we continue to the explode view. Before this we have the dimension view, right? So the explode view we can see there is a lot of the part. We can see the close, each section have the closed lid, and section A for the solid, section B is for the oil filter, for the filter oil, and the section C is actually for the water, the wastewater already cleaned out from the oil. So this is a bottle for the oil to get oil can store here. You can see. So the basket, for I zoom this basket filter is for filter the solid waste when the water through this part, when it can filter the solid part. And to detect the solid part is we have the ultrasonic sensor here to measure the level of the solid. If the level of solid is reach the high level, so they can send the info to the display or to the apps. So the section A actually for the solid part. So I'll continue to the section B. Section B, they have a closed lid to prevent the smell of the waste come out to our environment, so it make sure it can close. And so the motor is for the opening the valve for the oil to throughout for the piping this, right? So the heater is to have separable between the oil and the heater easily. If you don't have the heater, it also can, but it can take longer time to separate it. So they have a resistance sensor for the oil. They detect the resistance for the oil to make sure it is water of the oil. So these are for the part of the oil and display panel or monitor the system inside this product. So the bottle for the bottle, and you can see the section C and the close lid. I'll go to the summary, see the part of. So zoom out. This is all the part which is inside this product. So this part is show how the water throughout to our product. So you can see they have a 3 section, how it move inside the product. So thank you very much. Hello to the panel, and I'm Amirul Izwan. I will continue to the mechanical drawing. So I already explained in my video, so I just show the picture of the product only. So the design is they have a front and a back, and we have the isometric drawing is overview, right side, left side, and the expert view also I have explained in my video.
Hello everyone, I am Phong Oika. Today I will present the final presentation for this IED project, which is Modern Intelligent Sink for Drainage Management System. So first of all, I will present about the electrical drawing part. So now I will show you the electrical simulation. Okay, this is the electrical drawing part. For this electrical drawing, it consists two parts, that is part A and part B. The components that I use for this electrical drawing in part A is ultrasonic sensor, port HG, and Arduino Uno. While the components for part B is ultrasonic sensor, LCD display, heater, 3 LED, 3 resistor sensor, virtual terminal, and motor. For part A, the function for ultrasonic sensor in this project is to detect the distance for solid waste, while the function for ultrasonic sensor in part B is to measure the level of water. However, the LCD display and the virtual terminal actually is almost same function. Two of them can show the results in centimeter and inches, while this resistor sensor is to detect whether got oil came in the tank or not. If the oil didn't have came in the tank, means the virtual terminal will show the result whether got detected or not detected. Okay, now I will explain detailedly about this electrical drawing in part A and part B. For part A, how we want to make sure this ultrasonic sensor can display the accurate result. So I will show you the running simulation. Okay, this is the result here. For I have add on this port HG. By click this positive sign, the virtual terminal will show the result is increases. Here, this one is increases. If we click the negative sign, means the level for solid waste is decreases. So the value that you display on the virtual terminal is decreases. Can you differentiate? This one is increases, this one is decreases, this one is decreases because just now I clicked this negative sign 2 times already. Okay, But for this detect oil is for the resistor sensor. Here I have put the logic step. If I click 0, I click in 0, means the result will come out, no detect. If I click 1, the result is come out detect oil. So it means the result show in the virtual terminal is only detect oil or no detect. Okay, now I will explain about this ultrasonic sensor to measure the level of water by using this LCD display the result. So I will running simulation. This one we just ignore it because just now I have already explained. So now we go through about this LCD display. I guess we should wait a minute because it's just running. So how we want to make sure this LCD display will function as well? Same as just now, I have add on this port HG to adjust positive and negative. Here is already come out the result in inches. So if I adjust the negative sign, see the result is decreases. So if the result below 50, the motor will stop to rotate. If I click this positive sign, okay, the result is above 50, so the motor will start to rotate and the LED will light up in blue color. Okay, same as just now. Just now if I click this one in 0, so the LED will didn't have light up, right? If I click in 1, then the LED will light out in green color. So for this ultrasonic sensor, same as just now this one, I only add this one, the port HG, to make sure this ultrasonic sensor can and this LCD display can function well. But two of them is using different display. One is for LCD, one is the virtual terminal. Besides that, the heater is to help the separation between the water and oil more fast based on their density. So the oil will filter out through the valve when the resistance sensor is detected. So now I will show you the simulation. Okay. Here I have put the switch. If I press, then the heater will change in different color. Yeah, see, it will change in different color based on their percent in heat up. So if 25%, mostly it will in pink color. This one is 50% in yellow color, and the 75 is orange color, and the 100% is the red color, is hot. So I guess that's it for me. Thank you.
Okay, now I will continue the software simulation. So for the software simulation, you can click on this link for the simulation part. Now I will present the software part, which is MISDMS notification application. So for this part, I will show you how our apps will work. So as you can see here, this is the user interface for our apps like this. Suppose I show this using emulator, but I'm really sorry because my laptop cannot support this emulator. So I will show you by using this presentation PowerPoint slide. So now, as you can see here, if you tap the Bluetooth icon, it will connect your phone with our product, like this. So this show it was connected. If you don't want to connect it or you want to disconnect it, you can click the icon here and it will disconnect your phone. So next, user must insert the value of weight for waste food section. We set it 2 kilogram maximum because if you keep the waste food for too long, it will become smelly and it will cause the air pollution. So that's why to prevent it from happen, we set the limit 2 kg. So user can enter either 1 kilo like that if they don't want to throw the food too frequently. They can set higher if they are really rajin. They can set it less than 1 kilo, so they can throw the waste product frequently. So next is the oil section. For this oil part, user must insert the volume of oil depend on the container capacity. So it depend on the capacity of the container to store the oil. So as example, let me show you in this apps. When I insert the value of weight like 1 kg for the food, 1 kilogram, and click the button, and when it reach the limit, it will send me the pop-up notification. So wait. So as you can see, this is the notification that I got when the waste food is reach the limit, like this. And this is the overall coding inside the MIT Apps Inventor. So that's all from me. Thank you. So next, this is the example for the demonstration part. So this all I already explained in my demonstration parts. So this is the overall coding in the MIT App Inventor. So for environment and sustainability, as you can see here, our product is very environment friendly. First, because we use the aluminium green material, which is light, easy to flexible and durable in strength. Other than that, this aluminium is corrosion resistant and immune to the harmful effect of the UV ray. So that's why our product can categorize in the environment friendly. Next, for the safety, the potential cause hazard gets stretched while handling the aluminum board. So the user might be get stretched if they don't carefully handle the aluminum board. So the reason is due to the sharp edge at the corner of the boards. So how we prevent the user from getting scratched, so we put the corner guard or the corner protector. So that's all.
Okay, now I will present about project management. Project management consists include Gantt chart. What is Gantt chart actually? Gantt chart is a visual view of task schedule over time. So I'm use this Gantt chart format for planning our IED project. Now I will show you the Gantt chart. This is the Gantt chart for our group. So I will shortly present about the activities that inside Gantt chart from week 1 until week 14. For week 1, that consists 2 activities, which is grouping and project briefing. For week 2 is the first presentation about problem defense. We will present about the task that given from our coordinator, problems and objective. So for week 3 is the problem solution. Think about the problem and solution for the product. Week 4 is the topic discussion. Divide the tasks within group member. Idea about the fishbone diagram problem and solutions from each individual. Then the week 5 is meeting with expert. Meeting with staff Jabatan Pengaliran and Saluran and drawing solution. For week 6 is the making prototype, drawing 2D or 3D expert view using SolidWorks or SketchUp, estimate costing. For week 7 is prepare slideshow, video for progress presentation, engineering calculation and electrical simulation. For week 8 is the second presentation, progress presentation, but due to the COVID-19 pandemic, our panelists request us to record the video for progress presentation and having Q&A section at week 8 to Google Meet. For week 9 is the rearrange task, improve drawing design, add more calculation on web test, and sign prototype. For week 10 and 11 is the programming using Arduino, like creating coding but using the software Arduino. For week 12 is the testing software, improve the prototype, prepare slideshow and video presentation. For final presentation, which is now I'm recording the video because due to COVID-19. So for week 13 is the Q&A section, and week 14 is the final report. Submit the final report through our supervisor. I guess that's it for me. Thank you.
So I will continue to the cost management. So the cost of the management is a material cost. They have Arduino Uno, which is they have all the part. The cost of the part is 281 ringgit. So the total order 40 quantity. So the weekly engineer for the outer price is so the working hour for the mechanical and software is 132, and so the mechanical engineer, electrical engineer and software engineer, they have the hours. Every part have the hours, and allow for the hours, 1 hour is 3 ringgit. So the total is for the mechanical engineer is 126, for the electrical 126, so and software engineer 144. So the initial investment for the outer is 90 ringgit. For engineer labor cost it is under 96, and over it cost it to 135, and the material cost is, well, budget is 300, so they are 281, so they have the balance. So I think this part for me, and thank you very much for the listening.